you doing? Awesome. So we have our standard scissors and glue. Y'all are in the process of cutting out the last of your items. I have got various color pens today, just because I'm going to be doing my usual marking things off, but you don't have to color code, okay? It's optional. Protractor and compass is a must today, so make sure you've got one of those handy and nearby. And you have cut out the entire first page of your notes. Please make sure the triangle and his friend the dot are together. If you separated them, that's okay. We'll put them back together. The graphs will be for tomorrow's lecture part 2, so you can set that off to the side for now, or cut them and put them in your baggie. When we're done with today's lecture, you should be able to complete the front half of your homework packet, which is this single-sided sheet. After tomorrow's lecture, you'll be able to handle the next page. Okay? We'll be starting today with the angles. We'll move on to the little circle things, and then we'll do the triangles. So if you want to stack them up in that order. And the angles. We'll be doing acute, right, obtuse, straight, and then reflex, the new one. That is the order we're working in today. So here was the last lecture that we did, was the lecture on reflections. And you've got a space to KWL that. You've taken a quiz on reflections, and you've taken a test on a bunch of stuff that came before. So instead of having you do an extra KWL page for that quiz and that test, I'm going to ask you to find the section that question that you're looking at belongs to, and putting it into the KWL for that section. So if your I need to learn something question came from, say, the slope section, go back to the slope notes and put that question in with those. So that way you're referencing kind of the same sort of section. All right? Which means today's notes are going to begin here on the very next page.
Are you going to take up 2 pages or 1 page?
We are going to take up 2 pages today, 2 full pages, and likely 2 full pages tomorrow. So I'm going to go ahead and set myself up for 2 full pages today.
Is it complicated or is it just that?
It just takes up a lot of room. Yeah. We're going to have a lot of pictures, and one of the pictures is going to take up almost an entire page. Not that there's a lot to draw. All right, so take a few moments, set up your title and objective. Today is the 27th of October. Halloween fast approaches. Yeah, either my daughter and I are going shopping for our costumes today after school.
So, Miss, we should just get 2 colors.
You're welcome to get 2 colors just in case. I'm going to use purple, which is my recall color. I've got, I think I'm going to switch out to my yellow highlighter today to do the bars, between important things. And then I've got my blue for starting an example, and I've got my red for this is a new vocabulary word. Yeah, but I'm not doing any kind of color coding algebra yet. That'll be tomorrow. Can anyone guess why the very first song played today when you got in was our theme song today?
Because we're doing rotations.
Because we're doing rotations, and the song was... You spin me right round, baby, right round, like a record, baby. Yeah. Round, round, yep. I'm just scribbling in my objectives. All right, we're going to start off with a huge recall section. We're going to look back at our angle classifications. And we worked with 4 angles that we classified. The first angle that we classified was the acute angle. What were the angle measures that an angle needed to have to be considered acute? Let's see.
Less than 90.
Less than 90, but greater than?
0. Oh, 180.
Bigger than 0.
Looking up to is
Yeah. Bigger than 0, less than 190. That will give us a very cute angle. Very cute angle. Whoa.
Why are you guys so wild? Oh, look.
You should just drop things. It's okay. And the right angle. How many degrees did our angle have to be
exactly
Right. You said exactly
90.
90. Okay. So I had a hard time hearing you because the bell rang kind of in the middle of that, and then my brain melted out my ears. After the right angle, we had the obtuse angle. What was its measurements?
More than 90, but less than 180.
Beautiful. And it was done in unison. I'm very happy. After that was the straight angle. What was its measure?
It has to equal to 180.
Beautiful. Now, do y'all recall when we were first doing this section, I said, and there's another angle out there. I don't remember what it's called, but its measurement is like it's bigger than 180, but it's smaller than 360, and it's weird, and I don't remember its name right now, so we'll do it later. Do you kind of remember that?
Yeah.
A little bit, yeah. So here we go. We're going to deal with it now. It's the reflex angle.
You don't kind
It kind of does look like an obtuse angle, but let's look at the obtuse really quick. Do you see this arc right here? That means that that's what we're looking at. That's the measurement that we're interested in, and so this is what we're going to be using to classify the angle. Look at the reflex angle. Where is that arc?
On the back of it.
On what looks like the back of it. It's out this way. So this is the angle that we're measuring, and so this is the measurement that is going to tell us what kind of angle it is. It's a reflex angle. We may have some reflex angles as we go through this rotation section. The reflex angle is definitely going to come back when we start looking at some other figures. I'll give you a few moments to catch up on this. Okay. Making sure that I had enough glue. I'm going to go ahead and make this match all the rest of them while I wait for you guys. I'm just coloring in so that they're easier to see. I'm getting my kindergarten moment on. Coloring! Whoa, it's blurry.
I remember when they would let us have playtime. That was a best time. I would always go for the kitchen.
The kitchen set? All right, let's kick off all of our vocabulary. And we've got quite a few words to get through. But let's start with a recall. What is a transformation?
It's a change.
It's a chance?
Change.
Oh, it's a change. Yeah. A transformation is any kind of change that we're going to do on the figure. Now, back in the translation section, when I gave you the homework for translations, I said, give me the definition for an isometric transformation. But I didn't put it in notes. I put it in one of the videos that I didn't require you to see that I had cut outside of class. And I included it as one of the questions, one of the conditional statement work on that particular homework assignment. Do y'all remember what that definition was for isometric transformation?
A change without changing the shape.
Yeah, it's a change you make that doesn't change the size or the shape. So formally, we are going to say that is a transformation that preserves.
Isometric transformation?
Yes, ma'am. A transformation that preserves congruence. Which means that when you're done doing whatever change you need to do to your pre-image, the image has the same size and the same shape as the original. So there's your formal definition. And let's look at transformation that preserves congruence. We've already studied 2 isometric transformations. We've done the translation, slide it around. We've done the reflection, flip it over like a pancake. We're going to do the last isometric transformation, which is the rotation. What's a rotation?
Where like it moves, like it clockwise or
Yeah. Yeah.
circle-ish.
It turns, it spins, it goes clockwise or counterclockwise. It's our song of the day.
You spin
Me right round, baby, right round, like a rotation, round, round, right round. Yeah, that's a rotation, is the song. But as we are working to construct rotations and as we're looking to talk about them, we have to discuss 3 important aspects of rotations before we can actually get into it. Here's the first one. The first thing we need to talk about is the center of rotation. The center of rotation is a point that doesn't move, so it is fixed. And it's the point around which the rotation occurs. Y'all have seen the old time record players, yes?
Mhm.
And that's the post that you put the record on? That has the hole in the middle?
Oh yeah.
Yeah, that's the center of rotation, that little post. Now when you do this line here, to separate it, stop at the end of that last word. Don't go all the way across. We're going to draw a little figure, and I want you to have room for it. The second thing that you need to think about when you're talking about rotations, now that you've got the center, you need to think about how far you are rotating. And that's given by the angle of rotation. It's the angle that gets formed between the image and the pre-image. And then that line goes all the way across. Okay, I'm going to scoot everything over to the left a little bit. And then I'm going to zoom in so that you can see the figure that I'm about to draw. And I'd like you to sketch this in your notes as well. Because this one doesn't have to be precise. So we're going to have a center of rotation over here. That's this dot. And then I'm going to have some figure over here. Little smiley face. And you see how it's kind of connected, if you imagine it's connected by a string to the top of his head, to the center of rotation? Well, the angle of rotation is going to be this angle right here that we create between like 2 strings that are attached to our image and our pre-image. Pretend they're the same size.
Oh.
Okay? So this right here is our angle of rotation. We're going to be starting to use a new notation for angle. It looks like an O or a 0 that you've put a belt on it, but you didn't pull the belt tight to turn it into a number 8. Okay, it's just a 0. This symbol is called theta, spelled this way in English. It looks like it's spelled the ta, but it said theta. It's a Greek letter, kind of like pi, and it's their letter for the TH sound. So instead of putting 2 letters together for the sound, they have just one symbol. And
Theta.
yeah, theta. And this variable is going to use be used to represent angle measure. Represent angle measures. Okay, so no longer will we be using x as the variable for angle measures. From here on out, we'll be using theta as our symbol for angle measures. And this system of using theta will continue on for you well into the upper mathematics in through college, okay? So this will be the symbol for angle measures. All right, questions on the center of rotation or the angle of rotation? We're good so far? I see someone still writing, I'll wait. Yeah? All right. I'm out of room on this page, but if you have at least 4 lines available on the bottom of that one, you can continue going. The last thing that you need to think about when you're talking rotations, we have the center, so we know where we're rotating around. We have the angle of rotation, so we know how far we're going. But now we need to think about which direction we are going to be rotating in. So we need to consider the direction of rotation. And this is where the little arrows come into play. So glue your arrows down. Give yourself some space between them so that way they're not smashed together. This glue stick is way done. Oh, I missed. I'll pick it up later. Don't worry about it. That was my fault. I'll get it later. Ugh. All right. So I'm going to put the one that's spinning to the left over here and the one that is spinning to the right over here. And now it looks like my notebook has eyes staring at me. Going all crazy.
I was supposed to put it separately.
Just so that you have a bit more room. If you didn't cut them separately, it's okay.
Oh, man.
But this way I can space them out so that way my protractor makes a cool little face. So.
Does that say direction?
It says direction of rotation. Yes, sir, indeed. All right, so one of these is what's called clockwise motion, and the other one is counterclockwise.
Clockwise is the right.
This one.
Yes.
This one is clockwise because when you have an old-timey clock with the hands, 12 is here, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so because the hands spin in that direction, that's called clockwise, which means the other one is counterclockwise because it spins in the contrary motion of the clock. Yeah, backwards. And because I am lazy, I want to abbreviate these. So counterclockwise will be CCW and clockwise will be CW. Your homework, quizzes, and tests will have the full words written out, but when I'm doing notes, I am going to abbreviate. Let's do an example. This example will take up the rest of the page. So if you're down at the bottom with a couple lines left, go to a brand new sheet of paper. If you've just used the direction of rotation at the very top, you've got plenty of room at the bottom of your paper to keep going. Okay. So this example is going to ask you to draw the rotation of triangle. I need to name a triangle. 3 points, go.
2, C,
C,
You.
U,
B.
and B. Draw the rotation of triangle CUB about, and now I need to name the center of rotation. Another point, go. Somewhere over here.
L.
Somewhere over here.
T.
T.
I.
Now we need to know what direction. Clockwise or counterclockwise?
Wait, what's
Clockwise.
that perceiving?
About. Let me zoom in a little bit more.
What did you say we spelled?
Cub. Draw the rotation of triangle cub about T clockwise. Now I need to know how far. What's my angle of rotation? Somewhere between 0 and 360.
90.
90? Does anyone want to see anything else? What were you going to say? What number were you going to give?
What?
What angle measure?
7.
27.
Bro.
What others? We can go crazy, dude, and be like
270.
47, 260. We've got all sorts of angle measures that we could do. Okay? 360. Okay.
350.
359.
I'm scared.
I am going to do 90 degrees. It is one of the simpler ones. You're welcome to challenge yourself and attempt any of the others. The process will remain the same. You're just going to use a different angle measure. Okay? Let's start off first by writing the directions of how we're going to actually do the construction, and then we'll draw the rotation. Okay?
Wait, so we need to have all those numbers?
No, you can just write the one that you're going to do. I took notes on all the ones. I'm doing it with 90 degrees. All right, the first thing you need to do is draw a segment from vertex to center of rotation. Pick any vertex you want, start there, draw a segment from it to the center of rotation. Once you have that segment, you're going to measure, mark, and draw the angle of rotation. But you've got to pay extra special attention to which direction you're drawing it in and which direction you have been asked to draw it in. Unless stated, always assume counterclockwise. I'll go back up and I'll write it in a moment. The third step is to construct some congruent segments. So 3 steps, that's all you need. Who else watches it? Ujinosa? No? No, okay. So first step, draw a segment. Second step, measure, mark, draw. Third step, construct. Now I had stated that unless stated otherwise, you are to assume counterclockwise rotation. So I'm going to show you what I've added. At the top of our notes, here next to counterclockwise, you're going to assume this one unless you are told differently. Because I think on your classwork, I didn't tell you which direction of rotation. So you're going to assume it's this one. Grab your triangle with his best friend, the dot, and trim off some of the extra white that you may have around it. But don't cut off the dot. If you did on accident, it's okay. It just means that you'll have to draw your center of rotation in. Now you have complete freedom of choice of where to glue this into your notebook. Okay? But you have to think about something before you glue it down. You are doing a rotation, which means you need to have enough room for your original pre-image and whatever you're rotating it to. So think, what degree did I say I want to rotate this to?
90.
And which direction?
Counterclockwise.
Okay, so you're doing it counter. We had said originally clockwise.
Oh, I didn't know you had said
It's-
exactly what direction.
It's okay. We had stated, but you're right. If you didn't think there was stated, assume it's counter. So good instincts.
How do you do a triangle like that? And your dad is
Like that.
That's
Which
different.
came from that. See, it's this. It's this figure. I just trimmed it.
Oh, because it looks different.
I just trimmed it. That's all.
Oh.
Yeah. I trimmed it so I wouldn't have extra paper. That's all.
I did mine a lot.
It's okay. All right. So for those of you who are going to be doing the clockwise rotation with me, 90 degrees, putting it anywhere down here will give you enough room to rotate. And you can check that by holding it at the point of rotation, the center of rotation, and kind of spinning it around your finger and making sure that you're not going to run out of paper or run into anything important. Okay? This seems like a good place for me to glue it in because I'm going to be rotating it this way. So I'm going to glue right there. You take a moment, you decide where you want to glue it. Make sure that you spin it around so that way you know it's going to stay, going to have enough room for you. And we're ready to begin our construction. Step 1. Well, I should label first. Okay, this is triangle CUB. CUB, and the center of rotation is T. I'm also going to go clockwise, and so I'm going to draw in an arrow telling me which direction is clockwise. You don't have to put this arrow in there, but I find that it helps me remember which direction to go. And when I start putting all the little guidelines in there to do the construction, this will help me so I don't have to think so hard later. All right, first step says, draw a segment from vertex to center of rotation. Pick a vertex, C, all right, and I'm going to draw a segment between it and my center of rotation, T.
Is it better if you do the pencil?
I'd recommend pencil just in case you, like I put mine in the wrong spot. So I'm going to erase it and try again. I didn't quite hit the center of rotation. There we go. Now I'm gonna urge you to take extra care to make sure that things are really precise, because with these rotations, as we start getting bigger and bigger things rotating, if we're not super precise with our degree measurements and some of our line segments, the figure's gonna end up in the wrong place really fast. Okay? All right, next thing to do is measure and mark so that you can draw your angle of rotation. So use your vertex finder and put the center of rotation in the vertex finder. And then line up the segment that you drew with the 0 line. Now here's where you have to be careful with direction of rotation. I labeled that I'm rotating this way, and so I want the angle measures to be on this side of my angle. If you're rotating counterclockwise, you'll have to put your protractor facing this direction so that way those angle measures end up going this direction. Okay? So this is why I like putting in this little reminder of which direction I'm going. Okay, so setting it up. And I'm going to go to 90 degrees.
Is that the reason so straight? The bottom?
This bottom one right here, I use the straight edge of my protractor.
No, like I know, but like it's in the middle of it, and mine's like slanted like that.
Oh, just how I glued it in.
Okay.
Yeah. And it doesn't matter, you're still going to end up with the same rotation. Put the phone up, girls. Thank you. Unless you were texting me. No? Okay. All right, I'm doing 90 degrees, so I'm going to come up here to the 90-degree mark. You can mark either on the inside of your protractor or on the outside of your protractor. It doesn't matter which, you're still going to get the same angle measurement. And it depends on what is going on over here, where text is, basically. Okay? Once you have that marked, spin your protractor around to get to the straight edge and draw your angle of rotation. Take your compass. Measure out the distance between the center of rotation and the point that you're rotating. And then draw an arc so that it intersects the other part of your angle of rotation. Okay? You don't have to have this entire arc down. The only part that is important is right here. This is the only part that is of great importance. The rest of the arc is just there to show you that you could, if you wanted, go from this point and just spin your compass all the way around until you hit that line. Where those two things intersect is the rotation of that point. Repeat those 3 steps for every vertex in your figure. Drawing a segment between the vertex and the center of rotation. I'm putting my center of rotation in the vertex finder of my protractor, lining up the 0 line, marking out 90 degrees.
I don't get this part. Okay, we put the line from B to T, right?
Yeah, whichever one that
And
you're
then
doing.
How do you do it to equal 90?
I'm going up to where the 90 is, and I'm following that big line, and I'm marking it next to my protractor. That is where 90 degrees is supposed to be. It can be under the protractor, yes, but it needs to be right at whatever angle you've been given. Once you have that mark, draw out your angle of rotation from your center. Use your compass to measure the distance between the center of rotation and the point that you are rotating. And then draw your arc. Again, this is a moment where you don't have to draw this arc out here, though you're welcome to. You're really just interested in where that arc intersects the angle of rotation. That is the rotation of that point U prime. Repeat for your final vertex.
Where'd you get the radius for
For this, right here.
Oh,
Bless you. Oh, well, that too.
Thank you.
You're welcome.
Okay, so my throat
It's Pikachu. What happens when you sneeze when your throat picas?
I remember Pikachu. They're all into it.
Once you have all of your points rotated, take a straight edge and connect them in the same order that they were connected in the pre-image. U is connected to C, and so U prime must be connected to C prime. CB are connected to each other, so C prime must be connected to B prime. B is connected to U, and so B prime is connected to U prime. Once I have drawn in all my sides, my rotation is complete. Where did I lose you?
When you drew the second thing with the compass?
This one?
Yes.
I went from center of rotation to this vertex, And then I just drew a big arc from there until I ran into that line of rotation that I had put, or that the other part of the angle of rotation.
I did it wrong. I have no idea what I did.
Okay, no problem. I'll go around and look just now. All right, that's it. Thank you very much.